As you view this RStudio code, I will elaborate on how this machine learning accomplished in R will provide insight around what makes a healthy city. Data scientists often have an understanding of the features of their historical case data, as well as knowing what end state they want to predict for each case. This is known as a supervised learning problem. But what if we have data with a number of features, like the 27 health-related survey questions in the 500 Healthy City Initiative that is sponsored by the CDC, and we are hunting for some interesting correlations. But we are not quite sure if we want to put forth any kind of hypotheses. In this 500 city health example, and as seen in the R programming from this video, the machine learning effort is an unsupervised learning problem. It is unsupervised in that we are looking for what the algorithms uncover and trying to understand what is interesting. From that, we might be informed around what a good predictive target is and what are some influential features coming from the 27 survey questions. This scenario lends itself well to a clustering strategy. We will use k-means as seen in this video to achieve our clustering, and we will also plot using the cluster plot R function. This architecture plus data flow will process the R code in a fully scalable fashion versus being limited to the memory and CPU on the data scientist's laptop where RStudio is running. In addition to the scale benefits of running the R code in Azure SQL DB, because R can be complex and very processor and memory intensive, we also benefit in taking the data scientist's effort in R and making it more maintainable as well as reusable to any visualization platform that knows how to execute a stored procedure. In our case, the visualization platform will be Power BI. The algorithm and data processing in the R code, which could also be Python, is now executed in the cloud and within the same process as the Azure SQL DB instance that is managing the 800,000 rows of 500 Healthy City Initiative. Now with Power BI Desktop, which is a free analytics and visualizations authoring tool, we can get data from our Azure SQL DB instance and execute the stored procedure to retrieve the cluster identifiers for each city. For the R graphics that we executed in the R code from RStudio using the cluster plot function, we can copy that code directly into the Power BI Desktop where the supporting cluster identification data is populated from the aforementioned stored procedure that we executed. Now watch a hypothetical session as an analyst or an end user will drill around and slice the visuals as we wrap up what we've discussed. We have seen how we can take the incredible work our data scientists have performed in RStudio using R, again, which could also be Python using a tool like Spider, and then working with a data professional, taking that R code that otherwise was stovepiped and unscalable, running on the data scientist development laptop, and we've made the R code maintainable, scalable, and reusable by executing it close to the supporting case data residing in Azure SQL DB. We then performed our R charting within Power BI Desktop that pulls the cluster data from the SQL stored procedure that executed our data processing and algorithm processing R code. And finally, mashing up the stored procedure results with the raw detailed data to produce some staggering visualizations. Visualizations that allow us to understand more about the 500 Healthy City survey questions, their impact on overall healthy city, and the correlations therein. And now that the report is published, the analyst or end user can ask questions like, why did some cities land in certain clusters and others not? Why in the same cluster were some preventative measure survey questions polling high, but also some unhealthy behavior survey questions polling high? Why does it look like cluster 6, the light blue cluster in the scatter chart, tend to represent cities with the highest survey responses to unhealthy outcome questions? And many other possible questions and drill paths can be performed and hopefully answered using the rich visualizations we have authored. This end-to-end rich visualization, unprecedented solution brings an unsupervised learning problem to the fingertips of casual users or analysts that want to slice, click, and test their own ideas and hypotheses.